This is the video solution to the horizontal projectile motion review problem. Example number 2, this assumes you know Newton's 3 laws of motion as well as some kinematics. A toy car rolls horizontally off a table that is 1 meter above the floor at 2 meters per second. The car lands 0.9035 meters from the edge of the table along the floor. How much time did the toy car spend in the air? So here's my toy car, nothing really elaborate, just a dot, and it's going to be traveling in this arc path motion. Wherever I start, I'm going to make that my initial position of equal to 0. And it's going to fall down 1 meter, so I'm going to make that negative 1 meter, and over 0.9035 meters. And it's going off the table horizontally at 2 meters per second. And when it's off the table in the air, the only force acting on it is gravity, because we're always going to neglect air resistance. So I've got the force of gravity going down. Here's my strategy. I'm going to find the time in the air using vertical givens, or I can find the time in the air using horizontal givens, so I have a choice. Let's organize my work. I need a data table, or a table of givens. So I need all my kinematics variables. That's a VO, X, TVA. A long time ago, my students told me that I could memorize that as Vox TVA. Since I have two columns, two accelerations, I'm going to have two columns in my table of givens. One column for the vertical acceleration, that's going to be due to gravity, and horizontally, my other acceleration is going to be 0 because there are no forces acting horizontally. So this is how I organize my work. Since it's traveling off the table horizontally, the vertical initial velocity is going to be 0. And since there's no force acting horizontally, the acceleration horizontally is also going to be 0. The problem tells me it's traveling 2 meters per second off the table, so horizontally V0 is equal to 2. That's where it goes in the space of the givens table. It's falling down 1 meter, so that's negative 1 meter, and it's moving over 0.9035 meters, so there's 0.9035 meters. There we go. And the acceleration vertically is negative 9.8 meters per second squared because gravity is what's doing the accelerating, and all objects accelerate the same without air resistance near the surface of the Earth. So we're all set. Now let's look at the horizontal givens to solve this problem. Horizontally, I know I have V0, X, A, and I want T. So I'm going to use my X equals X0 plus V0 T plus 1 FAT squared. X0 is equal to 0. The acceleration is also equal to 0 horizontally. So I look at that square in my table and see where the 0 is. That means X is equal to V0 T. For this level of physics, that's always going to be true horizontally, that you're just going to have X equal to V0 times T without an acceleration. I'll rearrange this for T. So T is equal to X over V0. And at this point, I'm all set. Just put in my numbers for my horizontal list of givens, and I get 0.452 seconds. So I'm done. Or I could try my other strategy, which is using the vertical givens. Let's just see how the two compare. So again, I've got V0, X, I'm looking for T, and I have A, so I'll use X equals X0 plus V0 T plus 1 FAT squared. X0 is equal to 0, V0 is equal to 0, so they're going to go away. This makes the equation X equal to 1/2 AT squared. I'm going to change it to Y and G, so the X becomes Y and the A becomes G, just because I'm talking about vertical motion. So I'll solve this for T. T is equal to 2Y over G, square root of 2Y over G. So T is equal to the square root of 2 times negative 1 meter divided by negative 9.8 meters per second squared. And when I do the math, I get the same answer, 0.452. And we'd expect that because it takes that much time to fall down a meter, and in that much time it also travels 0.9035 meters. So the two times should be the same because that's when the ball stops moving when it hits the ground.